Okay, hello trig fans. Today we're going to cover trig equations. Okay, so trig equations. Okay, so we're going to start out with a couple basic equations here. So the first one is a linear. Okay, so I have 2 cosine of theta is equal to 1. What you need to do first here, before, well, let's just kind of get started, is we're going to solve for cosine of theta. All right, we have to solve for the trig function. So we're going to divide both sides by 2. And we're going to get cosine of theta is equal to 1/2. Now this is the deal. It's kind of like what we did before with the arc cosine. But we don't have to really worry about it being in range, okay, because there's no arc cosine here. It's literally just saying the cosine of theta is equal to 1/2. So we don't have to worry about range. But I will tell you that the domain for all these problems is going to be between 0 and 2 pi. Or, if we do it in degrees, 0 and 360 degrees. Okay, notice it includes the 0, and it doesn't include the 2 pi or the 360. That's why you have the parentheses in the bracket. Okay? So, a couple things we're going to do in these problems. And I always tell you guys to sketch pictures because pictures are just really, really important. Couple steps here. The first step is you want to, since it's cosine of theta is equal to 1/2, you want to sketch the quadrants. Okay, so in other words, this one is a positive, cosine is positive here. So what you're going to do is you're going to say, oh, where's cosine positive? Cosine is positive here and here. Because remember, all students take calculus. Okay, so we know we're going to be in these 2 quadrants. We're going to be in quadrant 1 and 4. So the question you're going to say is the cosine of what angle? Cosine of what angle equals 1/2? Okay, and that is actually going to be our reference angle. So our reference angle in this case here is going to be pi over 3. So we're going to do this one in terms of pi. So we have a couple things here. One is making the sketch, which I did here. I kind of got a little messed up, but it's this quadrant and this quadrant. Okay, and our reference angle. So our answers, we're going to have basically, for many of the problems, we're going to have 2 answers. So we're in this quadrant, which is just pi over 3, right? And then if we're in this quadrant, remember it's 2 pi minus pi over 3. Just like if it was 360 minus the angle, it's 2 pi minus pi over 3, which is going to be 6 pi over 3 minus pi over 3 is 5 pi over 3. So actually that is my answer. I know I did a lot of writing here, but after this you're going to have to do all that work, and you get theta is equal to pi over 3 and 5 pi over 3. Now, if I didn't restrict the domain like this, if I just said, give me the answers, actually you have an infinite number of answers. Because what could I do with it? I could take that pi over 3, I could add 2 pi to it, I can get 7 pi over 3, I can add, so I can keep adding 2 pi's because it's coterminal, and there would be an answer. That's why I need to restrict its domain. Okay, so anyway, this is my answer here. Okay, let's try another problem. It's another linear problem. It's going to be -2 tangent of theta minus 1 equals 1. And the domain is between 0 and 2 pi. So we're going to add 1 to both sides. -2 tangent of theta is equal to 2. Divide both sides by -2. So tangent of theta is equal to -1. Now notice, guys, you got to be really careful. This is all algebra, which you learned a few years ago, but you have to be super careful with your algebra, because if you make a mistake with the sign, it is not going to be a pretty thing. Okay, you're going to get the wrong answer. Okay, so Once again, you're going to say, oh, tangent of theta, where is it? Negative. Well, tangent, remember, it's all students take calculus. So tangent is negative there and there. And my reference angle, of course, it's 1 or negative 1, is going to be pi over 4. We know that. That's a real common one. So if it's in this quadrant, remember, it's going to be theta is going to be pi minus pi over 4, which is 3 pi over 4. And then if it's in this quadrant, it's going to be 2 pi minus pi over 4, which is 8 pi over 4 minus pi over 4 is 7 pi over 4. So those are my answers. Theta is equal to 3 pi over 4 and 7 pi over 4. Okay, pretty easy. All right, let's try another one. Let's do a quadratic now. So we have 4 sine squared of x equals 1. Well, you got to solve for that trig function. So divide both sides by 4. So sine squared of x equals 1/4. And you take the square root of both sides. Now don't forget, this is what you learned in Algebra 1. When you take the square root, you'll get sine of x equals plus or minus 1/2. Very important. So if you notice, I really have two problems. I have sine of x equals 1/2 and sine of x equals negative 1/2. So you notice in the past problems, each problem gave us 2 answers. Well, in this case, I'm going to have 4 answers. So if I look at the first one, where's sine positive? Well, again, all students take calculus. So sine's positive there and there. And where's sine negative? Sine is negative in these 2 quadrants. So the key here is you get a reference angle, which happens, it's going to be the same for both of them. And so your reference angle is pi over 6. So that means this one's going to be pi over 6. This one's going to be pi minus pi over 6, which is 5 pi over 6. This one is going to be over here. That's going to be pi plus pi over 6, which is 7 pi over 6. And this one is going to be 2 pi minus pi over 6, which is 12 pi over 6 minus 1 pi over 6, so that's 11 pi over 6. So those are my answers. Theta is equal to, and I don't care the order, just list them, but it's going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so let's try another problem. It's another quadratic. It's sine of x plus 1, sine of x minus 1 equals 0. Now remember, in order to solve a quadratic, especially if this is in factored form already, it's got to be equal to 0. If that equals 1, can't do the problem. You got to do something different. All right, so it's equal to 0. So we have sine of x equals negative 1, sine of x equals positive 1. Okay, so I solved each one of those, right? And then now, how many answers do I have for each one of these? Well, in the past we've had 2 answers for each one, but you got to realize, guys, these are quadrantals. Okay, they're quadrantals, which means there's really only one answer for each one of these. Okay, so what you're asking yourselves, I'm not even going to make a sketch. I guess I could if you wanted, because you know you can do, in this case, sine of x equals y over r. So I'm looking for where this is either 1 or negative 1. And or you can just kind of remember it. And if you remember, sine of what is, let's do the 1 first. Sine of what is 1? Well, the sine of 90 degrees or pi over 2. That's one answer. And you remember here y is 1, and here y is negative 1. So for this guy, sine of x equals negative 1, you get x equals 3 pi over 2. And that's the answer for these. Okay. Notice, don't get confused, and we did that for arc, tangent, all the arc functions or inverse functions. This is negative pi over 2. This is not negative pi over 2 for this. This is 3 pi over 2. All right. So let's try another one, another quadratic. Sine squared of x minus 1 equals 0. You could recognize this is actually two different types of problems. Well, it's the same problem, but you can set up two different ways. One is you can factor, which is actually sine of x minus 1, sine of x plus 1 equals 0, right? It's just a difference of two squares, and then it's actually like the problem we had before. Or you could just add 1 to both sides, and you get sine squared of x equals 1. Take the square root of both sides, sine of x equals plus or minus 1. And then you get the exact same thing. Here you got the plus and minus over there. So same idea. The only nice thing about having it in factored form and solving it is that you don't forget, you don't have to worry about the plus or minus. It's already built into it. Here, if you forget the plus or minus, you can forget it more easily. All right. So this, it doesn't matter which one you do, but I just wanted to point out both of them. All right, let's try another quadratic. We get sine squared of x equals 2 sine of x minus 1. Well, whenever you see a squared term, you want to move everything to one side because that's you're trying to either factor. Obviously, the past problem we just had, it was just an x squared term, not an x term, so you can solve for that x squared term. This one, I haven't really, if I look at it, it's almost like this. It's almost like saying x squared equals 2x minus 1. So you'd move both of these to this side, and you would factor it. And remember, it's always nice to have a positive x squared term, because if you're trying to deal with a negative x squared term, then you got to deal with more signs, and it's not a really pleasant thing to do. So I'm going to subtract 2 sine of x and add 1 to both sides. So I get sine squared of x minus 2 sine of x plus 1 equals 0. So now you're factoring this. That problem. And that's a pretty easy problem to factor. X and x. That's going to be minus 1 and minus 1. So that's what I have here. I have sine of x minus 1, sine of x minus 1. And you don't have to write both of them out because it's the same thing. So sine of x minus 1 equals 0. So sine of x equals 1. And we've done this already. Where is equal to 1? It's equal to 1 at pi over 2. So this one actually just has one answer. All right. Let's do another quadratic. And actually, it's really a quartic. Quartic meaning fourth degree. All right, so I get sine to the fourth of x equals sine squared of x. All right, a really, really, really bad thing to do is to divide both sides by sine squared of x. That is a really bad thing to do because what happens is you're getting rid of one of the answers. You're getting rid of root. It's kind of like this. If I said x squared minus x equals 0, and you went, oh, I can just divide everything. I can get rid of x here and lose one of the answers. Now you have x minus 1 equals 0, so x equals 1. Well, technically, you should have factored that out. So you really have another answer. So you can't just divide stuff out without, you should just factor it out. Always remember you have to factor. And of course, it has to be set equal to 0. So the first thing I'm going to do is I'm going to subtract sine squared of x. And I get sine to the fourth of x minus sine squared of x equals 0. And then I factor sine squared x out. I get sine squared of x minus 1 equals 0. So sine squared of x equals 0. Sine squared of x minus 1 equals 0. And this one, if I take the square root of both sides, I just get sine of x equals 0. Well, how many answers do I have for this one? Actually, I have two answers, right? Right here and here. So two places. So it's basically at 0 and at pi. So that's my answer, 0 and pi. We've done this one already. It's sine squared of x equals 1. So sine of x equals plus or minus 1, which remember is up here and down there. So in this case here, it's pi over 2 and 3 pi over 2. So my answer, and again, I don't care the order, 0, pi, pi over 2, and 3 pi over 2. All right, another problem. So this is actually an identity problem. Okay, so you have cosine of 2x plus sine of x equals 0. Okay, this is brutal because you have a cosine and you have a sine. And really, to solve these problems, unless it's multiplication, you can't just solve for it. It's really difficult to solve for that. All right, but what we can do is if we can turn the whole thing into something in all of sines or something all of cosines, that's what we want to do. And if you recognize that, okay, which we talked about this just the past couple days, that's a double angle for cosine. So remember, cosine of 2x is cosine squared of x minus sine squared of x. It's 2 cosine squared of x minus 1, and it's 1 minus 2 sine squared of x. Well, the one that makes sense to use is this third one here, because that's going to give us everything in terms of sine. And then we can actually probably factor because you got a sine squared there. So we're going to replace this with 1 minus 2 sine squared of x, and then plus sine of x equals 0. Now, it's your call what you want to do, but I want to make this positive because, again, I don't want to deal with the negative. So you can either divide everything by -1 or you can move everything over. It doesn't matter. But I'm going to rewrite this as 2 sine squared of x minus sine of x minus 1 equals 0. Okay? And then this is just like saying 2x squared minus x minus 1 equals 0. And then if you factor that, you get 2x, x, and this is going to be minus 1 and plus 1, I believe. Okay, so in this case here, we're going to have 2 sine of x plus 1 and sine of x minus 1 equals 0. So I set each one of those equal to 0. And if I solve each one of these, I get sine of x equals -1/2 and sine of x equals 1. Well, we've done this already a few times. Sine of x is equal to 1 there, so x for this one is pi over 2. And this one, sine is negative here and here. The reference angle, sine of what is 1/2, and it's pi over 6. So if it's in the third quadrant here, it's going to be pi plus pi over 6, or 7 pi over 6. And if it's in this quadrant here, it's going to be 2 pi minus pi over 6, or 12 pi minus pi over 6, which is 11 pi over 6. So my answer for this problem is 7 pi over 6, 11 pi over 6, and pi over 2. Okay, so this one had 3 answers. But the key here, it's like you said, it's an identity. So look for something if it's got, if it's obviously if it's cosine, you got to pick one of these 3. Probably not picking this one, but maybe, or picking one of these 2. Like if this was plus, if that was plus cosine of x, then you definitely pick the second one because you want that in terms of all cosine. Okay, and then of course I could have a problem where it's sine of 2x. And just remember, that's the same thing as 2 sine of x cosine of x. So you can write it as an identity to split it up. All right. The last type of problem, or I shouldn't say the last type, but the last problem is this. Cosine of x minus 2 equals 0. Okay, so we get cosine, you're going to add 2 to both sides. Cosine of x equals 2. And then the question is, cosine of what is 2? Well, you guys should realize that's a ratio. Okay, and this is your x value, and this is your r value. That's impossible. Remember, for the values of what cosine can be, it can be between -1 and +1, including that. So this is equal to 2. So this one is no solution. All right? Make sense? So I know I said one last one, but now we have one last one. So here's one. If I said cosine squared of x equals cosine of x plus 2. Okay, you can move everything over. Cosine squared of x minus cosine of x minus 2 equals 0. You get a factor, so you get cosine of x, and it's going to be minus 2 and plus 1. That's going to give us the right combination. So you get cosine of x equals 2, cosine of x equals -1. Already, this one's no solution. This one, remember, this is going to be x over r. So where's x -1? It's right here. So this one is x equals pi. And that's the answer to that problem. X is equal to pi. So those are some basic solving equations with trig functions. I want to make one comment here. Notice we've been getting 2 answers for a lot of these problems. So like the first problem that I did was sine of x equals 1/2, and you came up with x is equal to pi over 6 and 5 pi over 6. All right. This is different than if I said, what is the arc sine of 1/2? Okay. This does not give you 2 answers. I want you to be really careful about that. That gives you 1 answer, as opposed to this one I'm saying, hey, what are the values of x? This one, as soon as you see the word arc, that's got to be in the range. So the range for this one is, remember, sine is here and here, so it's positive, so the answer to this problem would be pi over 6. Don't give me more than 1 answer. These all have 1 answer. If I said the arc sine of -1/2, well, you're down in this quadrant here. Remember what you do, it's negative of the reference angle, so negative of pi over 6. And that's your answer. So that has 1 answer. These can have 0, 1, 2, 3, 4. Can have as many answers. It all depends on what I ask for. Okay, so that's it, trig fans, and have a good day. Bye.